Hi everyone, welcome to Learn with Israel YouTube channel. So in this video we'll be treating JAMB chemistry question for episode 3, which will be from question 41 to 60. If you haven't subscribed to Learn with Israel YouTube channel, please subscribe now. And this number here, if you are interested in tutorial, joining chemistry tutorial, just chat this number, or for other subject tutorial, chat this number right here on WhatsApp to join the tutorial. And if you are interested in getting syllabus for any subject, just chat this number right here to get it for free. So let's dive into the question. Question 41. Sugar is separated from its impurity by A. Distillation, B. Evaporation, C. Precipitation, D. Crystallization. So let's start from crystallization. Crystallization is a method used to separate sugar from its impurity. Using crystallization, loss of sugar cannot occur. So crystallization is the best method to separate sugar from its impurity. So crystallization is the correct answer. Question 42. A difference between chemical and physical change is A. Heat is supplied, B. A new substance is formed, C. Oxygen is consumed, D. A reversible process occurs. So the significant difference between chemical change and physical change is that in physical change, the process is reversible and no new substance is formed. But in chemical change, the process is irreversible and new substance is formed. So option B is the correct answer. The difference between chemical and physical change is a new substance is formed. Question 43. The movement of liquid molecules from the surface of liquid to the gaseous phase is known as A. Brownian motion, B. Condensation, C. Evaporation, D. Liquefaction. So what's Brownian motion? Brownian motion is zigzag motion. Maybe smoke is going up in the air. It does not move straight or move in a particular direction. It moves in a zigzag motion. So the movement of liquid molecule from the surface of liquid to the gaseous phase is known as evaporation. Evaporation takes the shape of the liquid molecule to gaseous phase. Evaporation takes the shape of a liquid molecule to gaseous phase. So let's move to question 44. According to Charles' law, the volume of a gas becomes zero at A. 0 degrees Celsius, B. minus 100 degrees Celsius, C. minus 273 degrees Celsius, D. minus 373 degrees Celsius. So the absolute temperature for Charles' law is minus 273 degrees Celsius. Please note that because it's very essential. So minus 273 degrees Celsius is the correct answer. So let's move to the next question. Question 45. A gas occupies 30.0 dm³ at STP. What volume would it occupy at 91 degrees Celsius and 380 mmHg? So the general gas question, and the first thing to do is to write out our givens. So let's solve our givens. We have, since it is STP, so our P1 equals 760 mmHg. 760 mmHg is very constant. If you are solving a gas question, a general gas question, once it includes STP, you have to use 760 mmHg as the first prior. So let's continue. We have our T1. Our T1, since it is STP, we will use 273 Kelvin as our T1. Our V1 is 30.0 dm³. Remember, any question you are solving that includes STP, don't forget these two values. You just replace it, our P1 as 760 mmHg, and the T1 you replace it as 273 Kelvin, and the value left you input it in the second pressure and temperature, because this STP means standard temperature and pressure, and the standard temperature is 273 Kelvin and the standard pressure is 760 mmHg. So if you are not given the value for the first pressure and first temperature, once it includes STP, you just input these two values. It's very constant. It's very, very constant. So let's check for our P2. Our P2 is 380 mmHg. 380, so our pressure, second pressure, 380 mmHg, and our T2 is 91 degrees Celsius, but we can't leave it at 91. We need to convert it to Kelvin. And to convert to Kelvin, what do? You add it plus 273, because 273 is constant, and 91 plus 273 will give us 364 Kelvin. 364 Kelvin. So we are looking for what? Our V2. Our V2 is unknown. So we have P1 V1 over T1 equals P2 V2 over T2. So if we cross multiply, we have V2 equals P1 V1 T2, because they already multiplied, so we have P1 V1 multiplied by T2 over P2 T1. That's the one left. P2 V1. So our V2 equals, what's our P1? Our P1 is 760 multiplied by, what's our V1? Our V1 is 30 multiplied by our T2. Our T2 is 364 all over our P2. What's our P2? Our P2 is 380 divided, our P2 is 380. 380 multiplied by T1, which is 273. 273. Let's clean here. Let's write it here. So our V2 equals 760 multiplied by 30 multiplied by 364 over 380 multiplied by 273. So our V2 equals, let's see, DMQ. Can press your calculator to check it out. 80 dm cube is the correct answer. So let's check our option. It's in option D. 80 dm cube is the correct answer. So let's move to question 46. Before solving the question, you need to know where it emanates from, the topic of the question. So this is solubility question. The one we solved earlier is general gas question. And the formula is P1 V1 T1 equals P2 V2 T2. So we have to look for another parameter. Example, maybe I have to look for T2 here. We just make T2 the subject of the formula. I hope you understand that now. So solubility. Let's solve for solubility. The first thing to do, the question says, calculate the solubility in mole per dm cube of 40 grams of CuSO4 dissolved in 100 grams of water at 120 degrees Celsius. So we have Cu, which is copper. The molar mass is 64. Our S is 32. And our O, which is oxygen, is 16. Our sulfur, 32. And our O, which is oxygen, is 16. So the first thing is to solve for our molar mass. We need to know our molar mass. If we don't know our molar mass, there is no how we get our solubility. There are some things we need to get the answer before we can get our solubility. And the number one is molar mass. So CuSO4 molar mass equals, our Cu is 64 plus our S, which is 32, plus our O is 16 multiplied by the 4 here will give us 16 multiplied by 4 is 64. So if we multiply together, 64 plus 64 is 128, and 128 plus 32 is 160. So 160 grams per mole. You already know our mass. Our mass is 40. Our mass is 40 grams. And our molar mass is 160 grams. So we don't know our number of mole. We don't know our number of mole. The next thing to do is to calculate for number of mole. Our number of mole equals mass over molar mass. Our mass is 40 and our molar mass is what? 160. 160. 0 cancel 0. 4 divided by 16 is 0.25. 0.25. So our number of mole is 0.25. If you check the option, 0.25 mole per dm cube is there, but you can't just pick it. because we have not derived our solubility. So after that, we can't just go next to calculating solubility. We need to know our volume. What's our volume? Our volume is 100 grams of water, because I said it previous. I've done like all the episodes I've done previously. I've calculated this kind of question for people that have not understand it yet. Any time you see 100 grams of water, it equally represents 100 centimeter cube, because gram of water takes the shape of the container. So 100 grams of water also equals 100 centimeter cube. So our volume is 100 centimeter cube. But do you know what? You can't leave it like that. You have to convert to dm cube, because the question says calculate the solubility in mole per dm cube. So we need to calculate in what? In mole per dm cube. So to calculate in mole per dm cube, we have to divide by what? By 1000. Note that it's step by step. Firstly, we calculate our molar mass. After that, we know our number of mole, because to calculate number of mole, you need to know like your molar mass. So we already derive our number of mole. Now to volume. So let's divide by 1000. 100 divided by 1000 equals 0.1 dm cube. So now we are going to the real deal now. Solubility. The formula for solubility equals mole all over volume. Mole all over volume. You see? Assuming I already gone for 0.25 here, I would have picked the wrong answer. And assuming it's an exam, that's how I will have get it wrong. So you need to calculate it well and correctly. So our mole is 0.25 all over our volume, which is 0.1. And 0.25 divided by 0.1 will give us 2.50 mole per dm cube. 2.50 mole per dm cube. You can check it out. You can calculate it. 0.25 divided by 0.1 will give us 2.50 mole per dm cube. So in the option, it's in option A, 2.50 mole per dm cube. I hope you understand that now. So guys, if you haven't subscribed, please click that subscribe button now as we move to the next question. Question 47. The fundamental difference between the three states of matter is the dash. A, degree of movement of their particles. B, number of particles in each state. C, shape of container they occupy. D, shape of their particle. So the fundamental difference between the three states of matter, which include the solid, liquid, and gas, is the degree of their movement. They increase in the degree of their movement from solid to liquid to gas. So they increase. So the degree of movement in gas is more than that of solid, because from solid it increased to liquid, and from liquid it increased to gas. I hope you understand that now. Let's move to question 48. The liquescent substances are used for dash. A, cooling. B, wetting. C, melting. D, drying. The liquescent substances absorb water to form solution. So by doing that, they need to dry up the substance in order to form the solution. They absorb water in order to form the solution in the process of drying it. So drying is the correct answer. The liquescent substances are used for drying. Question 49. The gas that is used for the treatment of cancer is A, neon. B, radon. C, xenon. D, argon. So all these, including neon, radon, argon, and xenon, are all noble gas. But the gas used for treatment of cancer is radon. Radon is used for treatment of cancer by radiotherapy. Radiotherapy works in the hospital and is one of the lucrative courses that a science student can study. Radiotherapy uses radon to treat cancer. I hope you know that now. If you are asked that what's the work of radiotherapy, you should be able to define it with my explanation. Question 50. Of the following commonly used materials, the one that is not alloy is, so I'll break this down. Just watch me do that. A, steel. B, brass. C, bronze. D, copper. Let's start from steel. Steel is an alloy which combine two mixture, which is iron plus carbon. Iron plus carbon. For brass, it comprises of copper plus zinc. Brass comprises copper plus zinc, while bronze comprises of brass is also alloy. Alloy is like two or more mixture. So brass comprises of two mixture, which is copper and zinc, while bronze also comprises two mixture, which is copper plus tin. Copper plus tin. I hope you now know the difference between brass and bronze. They both possess copper, but for brass is zinc and for bronze is tin. And for copper is not an alloy. It's a transition metal but not an alloy. The following commonly used material, the one that is not alloy is copper. I hope you now understand now the differences between the options. So I will now give you the function of all these options. Steel, what is steel used for? Steel is used in construction instrument. The instrument they use, the construction material they used inside building site, steel is involved. While brass is used in musical instrument. Musical instrument, you can find brass there. And for bronze, it's used in medals. All these medals they will give to one who win a race or one who win a competition. The medal, you can find bronze in it. And for copper, anything electrical wire, you can find copper in electrical wire. So now please don't forget to subscribe to Learn with Israel YouTube channel. Hit that like button, share the video, and if you have any answer different from what I've picked above, just comment it in the comment section. And if you have any question to ask, drop it in the comment section. So now let's move to the next question. Question 51. What current in amperes will deposit 2.7 grams of aluminium in 2 hours? In what? In 2 hours. So let's solve. Our current, we are looking for our current. Our current is unknown. Our mass is 2.7. Our molar mass is 27 because aluminium atomic number is 13 and the molar mass is 27. Aluminium gains 3 electrons. So the number of moles will be 3. The number of moles will be 3 because aluminium gains 3 electrons. And our Faraday is constant, it's 96,500 C, and this C represents coulomb. What other thing? Our time is 2 hours. So we have to convert to seconds. 2 hours, 1 hour is 3,600 seconds, and we have to multiply by 2. So T equals 7,200 seconds. 7,200 seconds. Now, since we are done, so let's solve. Our I now equals the formula for current. This kind of question is N multiplied by F over molar mass multiplied by time. So our I, which is current, equals our mass is 2.7 multiplied by our number of moles, which is 3, multiplied by our Faraday, which is 96,500 over our molar mass is 27 multiplied by our time, which is 7,200. So if we multiply 2.7 multiplied by 3 multiplied by 96500, we will get 781,650. Press your calculator. This is the answer that you get. 7,200 will get 194,000. So 781,650 divided by 194,000 will give us 4.02. We can't leave it like that. We have to put the unit there, and the unit of current is ampere. So let's check the option. Yeah, it's in option C. 4 is the correct answer. So let's move to question 52. This question is under current electricity. Why this question? Let's calculate how many atoms are present in the 6.0 gram of magnesium. So let's write out our givens. The mass is 6 gram. The atomic number of magnesium is 12 and the molar mass is 24. So the molar mass of magnesium is 24. It's represented as mm. Molar mass is 24. So we need to get our number of moles before we can know the amount of atoms present in 6.0 gram of magnesium. So our number of moles equals 6 divided by 24, and 6 divided by 24 is 0.5 mole. 0.5 mole, because the number of mole units is mole. I treated that when we are treating unit and dimension in physics. If you haven't watched the video, go and watch the video right now. So after done with that, our number, we now calculate for number of atoms. Our number of atoms is unknown. So number of atoms equals our number of moles multiplied by our Avogadro number. So to get your number of moles, to get your number of atoms, you need to multiply your number of moles multiplied by Avogadro number. And Avogadro number is also equals to Avogadro constant. And what's Avogadro constant? Avogadro constant is 6.02 multiplied by 10 raised to power 23. That's the Avogadro constant. So our number of moles is 0.5 multiplied by 6.02 will give us, you don't need to add this multiplied by 10 times 10, 23. We are going to add it after the multiplication. 0.5 multiplied by 6.02 will give us 1.505 multiplied by 10 raised to power 23. This 23 here, which equals 1.05. We approximate 5 will turn to 1. We'll round it up to 1, and 1 plus this 0 will give us 1.51 times 10 raised to power 23. So 1.5, and let's check the option. Yeah, in option C, 1.51 times 10 raised to power 23 is the correct answer. Let's move to the next question. Question 53. The nucleus of an atom contains A protons only, B neutron only, C neutron and proton, D proton and electron. So the nucleus of atom contains proton, which is positively charged, contain proton, and neutron, which is neutral. So the nucleus of an atom contains proton, which is positively charged, and neutron, which is neutral. So the correct answer is neutron and proton. Question 54. 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d7, 4s2. An element with the electronic configuration above is A non-metal, B metal, C transition metal, D group 2 element. So let's add the number at the top. 2 plus 2, that's 4. 4 plus 6, that's 10. 10 plus 2, that's 12. 12 plus 6, 18. 18 plus 7, 25. 25 plus 2, that's 27. And if you check the first 30 element, the element with 27 is cobalt. That's why it's good, before you go and write that your exam, make sure you learn the first 30 elements of it. If you cannot learn first 30 elements, make sure you learn the first 20 elements from hydrogen to calcium. So the atomic number of 27 is cobalt.
Cobalt is a transition element filled with partially d orbital. As we can see the d orbital. So the correct answer is transition element. The element with the electronic configuration 1s2, 2s2, 2p3 is A oxygen, B chlorine, C nitrogen, D calcium. So we have the 1s2, 2 plus 2 plus 3 will give us 7. And if you count, we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, which is in the 7th. So nitrogen is the 7th. Question 56. 4 elements P, Q, R, and S have atomic number of 4, 10, 12, and 14 respectively. Which of these elements is a noble gas? Noble gas is the element that is fully filled. So our P is 4. So if we count hydrogen, helium, lithium, beryllium. So for P is beryllium. So option A is wrong. If we check for Q, we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Neon is 10, which is 2, 8. So it is fully filled. We have 2 up. We have 1, 2, 3, 4, 5, 6, 7, 8. You can see that is fully filled orbital. So the one that is noble gas is Q, which is neon.
Question 57. An element has two isotopes 20 and 22x present in ratio 1:3. The RAM of x should be, RAM means relative atomic mass. This is also under electronic configuration. So let's solve. The first thing to do is to add our ratio. Our ratio is 1:3. So 1 plus 3 give us 4. After doing that, we multiply the mass number here. We are looking for our relative atomic mass. We multiply the mass number here, which is 20. Because this is the atomic number, we have nothing to do with these two atomic numbers. We are dealing with the mass number. And the mass number is 20. So we now have 20 plus the first number of the ratio. So 20 multiplied by 1, multiply it plus 22, the second one, multiply by the 3. We now divide it by 1 plus 3. I hope you understand this simple math. 20, the mass number, multiplied by the first ratio with the second mass number, multiplied by the second ratio. So I hope you understand that now. So 20 multiplied by 1 is 20, plus 22 multiplied by 3 is what? 66. So 1 plus 3 is 4. So 20 plus 66 is 86. And 86 divided by 4 will give us 21.5. 80 divided by 4 is 20. While 80 divided by 4 is 20. We are left with 6. 6 divided by 4 is 1.5. So if we add it together, 20 plus 1.5 is equal to 21.5. For those that don't understand how I get the answer. So I hope with this, you understand it now. So let's move to question 58. The weakest attractive forces that can be observed between two molecules is A. Ionic, B. Covalent, C. Coordinate, Covalent, D. Van der Waals. So option D, Van der Waals is the weakest force between two molecules in a liquid. Is the weakest force between two molecules in a liquid. So Van der Waals is the correct answer. So if you are watching this video up to this moment and you have not subscribed, please subscribe now and hit that like button. Let's continue. Question 59. A hydrocarbon X with a molar mass of 26 consists of 92.3% carbon and 7.7% hydrogen. What is the molecular formula? I know most people find this question a bit complex, but I'll break it down for you guys. So the first thing to do is to divide the percentage of carbon by its molar mass and the percentage of hydrogen by its molar mass. So let's do that. We have carbon, we also have hydrogen. So the percentage is 92.3 divided by the molar mass of carbon is 12, while hydrogen 7.7 divided by the molar mass, which is 1. So 7.7 divided by 7.7 is 7.7. So 92.3 divided by 12. Press your calculator. 92.3 divided by 12 will give us 7.69, and if we approximate it, we will get 7.7. So for carbon 7.7, and for hydrogen is 7.7 also. So the next thing to do now is to write out. We now have CH. So let's calculate. Our C is 12 and our hydrogen is 1. So 12 plus 1 will give us 13. So let's calculate for the X. So our CHN, let's represent it as N, equals the molar mass 26. I hope you understand how we get it. CHN equals 26. So we represent this as the empirical formula. We are looking for what? Our molecular formula. So CHN, we already know that our CH is 13. So we can now say 13N equals 26. Let's divide both sides by 13 to get our subject of the formula, which is N. So 13 divided by 13, 13 divided by 26. 13 cancel 13. So our N equals 2. 13 divided by 26 is 2. So our N equals 2. So we can now write our molecular formula is CH2. CH2 with the 2 here. So 2 multiplied by C, we get C2. If you want to open the bracket, while 2 multiplied by H, we get H2. And the name of this C2H2 is ethyne. Ethyne, for those that don't know, is for this H2 is ethyne, and it is written as C triple bond C. C triple bond C. We have one H here and one H here. I'd already diving into organic chemistry. I hope you understand that now. So if we come and check it here, C2H2 is the correct answer. So let's move to the last question for episode 3. How can I have the general molecular formula of ACH2N minus 2CHO, BCH2N plus 1OH, CCH2N minus 1, BC2H2N minus 2OH? The general formula for alkanol, which is also known as alcohol, is OH. O what? OH. So if you check the option, we have 2OH here. You need to note this. It should be CH2N plus 1. That is the general formula for alkane. And since it is having the additional of OH, it will now be called alkanol. Alkanol. So the correct answer is option B, CH2N plus 1OH. The one here is also invisible. I just added here for clarity. So we've come to the end of this video. If you found this video helpful, please like, share and subscribe. Also share to your friend also preparing for this UTME exam. See you in my next video.